going to be solving equations by adding or subtracting. So solving equations by adding or subtracting. And I think this should look really familiar. So first I just figure I probably should say, well, what's an equation? And because that's going to come up, right, an equation for this. But basically, if you have an equation, it's something equals something. Equals something. Yeah, we're doing the really official math definitions here. But so an example could be something like x equals 4. It could be area of a circle is pi r squared. You know, basically you just need to have an equal sign, and you have to have something on either side of the equals. From there, you could go then down and say, so what's the solution of an equation? So that's my next thing. So solution of an equation. And for that, you have to go through and find out what the variable equals. So the solution of an equation is just going to be what the variable equals. I maybe should have said what number the variable equals. I'll maybe change that. You probably don't need to. In other words, if we're working with this pi r squared right here, area equals pi r squared, they give you a circle of radius 7. You know, you put the 7 in for the radius, and you do the math here, find out what a equals. You know, this one already is the solution. It's x equals 4. We know what x equals. Fair enough? Just trying to figure out what does the variable equal. The key to solving one of these equations is you look at what was done to the variable, and you do the inverse, opposite, operation to both sides. So I'll maybe put a little star for dramatic emphasis and say, to solve an equation, I'll do EQN to save a little bit of time to solve an equation. Look at what was done to the variable. And do the inverse operation to both sides. So do the inverse operation to both sides. That word inverse, if you want to kind of add a little notation to it, technically it's inverse. If you think opposite, a lot of people, that makes more sense to them. So like, what's the opposite of adding 7 to something? Subtracting 7. Technically, so that inverse of adding 7 is subtracting 7. Section 2 will be looking at multiplying and dividing. What's the opposite of dividing by 4? Multiplying by 4. So that's the inverse with these. So for this section, though, you could say addition and subtraction are inverse operations. Worth writing it, not worth writing? Seems like you got it, but you could write that if you wanted to. Addition and subtraction are inverse operations. Those two undo each other. Now, I'm going to be more honest with you about my thoughts towards a student than what I should be, because it makes me look like an idiot, like a jerk. Algebra 2 years ago, I learned a lot. I had a guy in after school. His name was Dave. He was struggling in Algebra 2. He was a sophomore, so he was like in an advanced grade, or an advanced class for his grade. And he was like in like the D range. And I just kind of had in my head that's like, he's just not overly good at math. You know, he just doesn't have math acumen. You know, so how he got in the advanced class, I don't know. But I'm working with him after school, and we're doing some more complex than what we're doing today, but solving equation stuff. And I wouldn't write this. This is just me getting excited. But so for him, okay, so I'm working with him after school, and found it's like this kid can do math in his head faster than I can. And I mean, it's like, I mean, and not just like something plus 4. I mean, he's doing like multiplications and squares. I mean, he's doing like multiplying like couple digit numbers in his head. I'm just like, what in the world? This kid's like off the charts. And so talked with him for a little while, and this is what we came up with. When he took algebra class, he saw x plus 4. The teacher's, now this is the process that you do. He looks at it and says x has to be 3, right? X is 3. 3 plus 4 is 7. Then he got to something like 2x equals 12. Well, x has to be 6. Then you get a little bit harder. 2x equals 12.25. 6.125. So he can do it in his head, right? Then we start giving him like, all right, what about 2x plus 4 equals, we'll say 18. So he'd be thinking in his head, okay, if I do this number, it's 7. So he could do all this stuff in his head, right? Problem is, he never learned how to do the steps when it was easy. Because he could just look at it and be like, well, the answer has to be this. Where that came to bite him then was now we start doing things like 2x squared equals 42.97. It's like, he doesn't have a clue how to start something like that, where you have the square and the 0.97. He didn't learn the steps. He was totally lost. So because of that, I'm going to do something that you're going to probably find to be totally obnoxious. And that I'm going to expect you, and I'm going to collect your homework like every day for several days, even though it's painful for me to do that every day. I'm going to be asking you to do this. So my first example is x plus 5 equals 14. The answer is 9. Problem is, if you write down x equals 9 or just 9, I'm not going to give you credit for doing this question. And the reason is I don't want you to turn into that former student that I had, that you can skate through this class, but then suddenly it's like you didn't learn the steps, so I'm going to try to make it worth your while to practice the steps by making you suffer if you don't. Okay, so when you get x plus 5 equals 14 in the book, I'm asking you to write down x plus 5 equals 14. Then I'm asking you to show that you're going to subtract 5 from both sides. And then I'm going to ask you to say x equals 9. It doesn't take long. Yes, I know it's obnoxious. Yes, I know most of you don't need it. But we're going to get to like multiplying and dividing. Then we're going to get to like multi-step ones. And we'll get to like absolute value ones. Please practice it now so that when you get to the really tough ones, you can do these suckers in your sleep and your life will be so much better in class. Second example, I'm going to take and make it a little bit more complex. X minus 7 equals a negative 2. Try to kind of bring up what we did before. X minus 7 equals negative 2. What do you do to both sides? Add 7. So then final answer is going to be x equals 5. Because we're going 7 to the right on the number line. It takes 2 to get back to 0. Then you have 5 more positive that you're going. X equals 5. Third example, this will be the last example that I do. Because we can only make it so complex with addition and subtraction, so the book starts throwing in some fractions. So m plus 3/7 equals 5 over 7. What do you do to both sides? Add, subtract. Yep, perfect. Minus 3 over 7, minus 3 over 7. When you're subtracting fractions, do you change the denominator? Nope. As long as you have common denominators, you know it's going to be something over 7. Numerator is 2. We're okay on subtracting fractions? Yep. Go ahead. All right. With that, the smart thing, this is what the book tells you should do in all of these. At this point in math, see, this is what I was just saying off the record, is that I'm not good at making people do it. If you want to check your answers to any of these, take your number and put it in for the variable and see if you get the right answer. So you can say, well, x is 5. Does 5 minus 7 equals negative 2? Punch it in, it does, or use your brain. Same thing here. Take the 9, put the 9 in for the x. 9 plus 5, yep, it equals 14. You know it works. So I'm not going to ask you at this point to show your checks, but you can. And when you're doing a quiz or a test for sure, it's like you can turn the thing in and know that you got every one of these right. The very last part is this. I wouldn't frantically copy all this down unless you want to. You're going to get this in geometry for sure. But here's a couple properties that you don't need to know the names of, but I want to at least put it in front of you so next year you'll be like, oh, I've seen that. Addition. So the addition property of equality. What that says, but they use letters, they say for all real numbers A and B, and they start out with A equals A, but essentially it's saying this. If you have 3 equals 3, then you could say 3 plus 2 equals 3 plus 2. That if you take and add the same thing to both sides of an equation, it's still going to be equals. And that's why at the very top of the screen, when we subtracted 3/7 to get m by itself, we had to subtract 3/7 from both sides. The official way that the book writes it is this here. They say, for all real numbers A and B, if A equals A, then A plus B equals A plus B. And you don't have to know that from memory in here, but does it make sense? And you'll see that. I'd be shocked if you didn't see that in geometry. You get the exact same thing as a subtraction property of equality. I'm not going to write the name, but if you have like a 3 equals 3, again, so 3 equals 3. If you would subtract 2 from both sides, 3 minus 2 is going to equal 3 minus 2. So for all real numbers A and B, if A equals A, A minus B is going to equal A minus B. So you've seen them at least.